Alright, question 5b. This is inverse function, so we begin. Let fx equal ln 1 plus e to the x for all of x. Show that f of x has an inverse function. Okay, so what we know is that inverse functions, a function can only have an inverse function if it is monotonic increasing or monotonic decreasing. That means its gradient is always positive or its gradient is always negative. So we just need to show that by differentiating f of x. So we get that f dash x is equal to, so when we differentiate logs, we have the derivative on the top and the original function on the bottom. So the derivative of 1 plus e to the x is in fact e to the x, and at the bottom is just simply what's in the function. Okay, so that's pretty straightforward right now. So we just need to show that it is positive for all of x. So if you realize for all of x, e to the x is always greater than 0. As you might observe the graph of e to the x, you realize that it is always going up. It never hits 0, thus it can never be negative. So if e to the x is greater than 0, then I believe that e to the x should be plus 1 is always greater than 1. Thus, if these two values are positive, then f dash x is always positive. So from this, f dash x is always greater than 0 for all real x. Therefore, fx is monotonic increasing. And what does that mean? That means that the function is what we call one-to-one. That means that for any x value, there is only strictly one y value. So if we flip it, as we do with our inverse, that means that every y value has a single x value. So that means that its inverse will also be one-to-one. Thus, f of x has a function, an inverse function, because its inverse is always one-to-one too. So that's pretty much how you do that problem.